Assalamualaikum. This is Abdul Rahman 231875 MTS4A from the class MTS4A, and today we will be discussing about the Arduino project that we have recently made. So firstly, I would like to apologize that I couldn't come from the laptop as my laptop went into some trouble and I couldn't troubleshoot it. So I'm gonna do it from my mobile and try to explain as best as I can the project I made. So firstly we will start with the schematic diagram of our Arduino. It's divided into sections. So this is basically the main chip ATmega 328 इसका नंबर है, and it consists of 28 pins जिसमें हम बारी बारी सबको डिस्कस करेंगे. तो अगर हम यहाँ टॉप पे आ जाएं, टॉप लेफ़्ट कॉर्नर पे, तो हमारे पास आप देख सकते हैं कि दो ऑसिलेटर्स हैं विद आवर 16 मेगाहर्ट्ज़ क्रिस्टल ऑसिलेटर, जो बेसिकली जिसका फंक्शन ये है कि ये क्लॉक प्रोवाइड करता है टू आवर आईसी. एंड इसमें हमने दो 22 पिकोफैरेड के कैपेसिटर्स भी यूज़ किए हैं ताकि हम वोल्टेज को रेगुलेट कर सकें, फिल्ट्रेशन कर सकें, वोल्टेज अप डाउन ना हो. फिर हमारे पास सर्किट आ जाता है ऑन द टॉप, जिसमें हमारा वीसीसी आ जाता है और हमारे रेगुलेटर्स आ जाते हैं. और स्टार्ट होता है डीसी बैरल जैक से. हम इसको यहाँ से इनपुट देते हैं एंड द करंट ट्रेवल्स थ्रू द डायोड. एंड डायोड यहाँ पे हमने यूज़ किया है ताकि हम लोग करंट फ्लो को रिड्यूस कर सकें अपने हिसाब से. यहाँ से हम इसको वी इन देते हैं जो कि LM7805 वोल्टेज रेगुलेटर में जाता है, विच बेसिकली कन्वर्ट्स द वोल्टेज इनटू 5 वोल्ट्स. जितनी वोल्टेज आ रही होगी उसको 5 वोल्ट में कर देगा एंड इट गोज़ टू द आउटपुट. एंड the same Vin goes to the another voltage regulator which is of 3.3 volts and वो 3.3 का वोल्टेज देता है आगे. यहाँ पे हमने दो 10 माइक्रोफैरेड के कैपेसिटर्स भी यूज़ किए हैं ताकि हम लोग वोल्टेज को फिल्ट्रेट कर सकें, हमारे सिग्नल्स ज़्यादा अप डाउन ना हो. और हमने रेजिस्टर्स यूज़ किए हैं ताकि हम करंट फ्लो को कंट्रोल कर सकें. LEDs हमने यूज़ की हैं यहाँ पे ताकि हम लोग चेक कर सकें कि हमारी पावर आ रही है या नहीं. ऑन द राइट साइड वही हमारा 3.3 वोल्ट का रेगुलेटर है. इसमें भी वी इन सिमिलरली यहीं से आ रहा है. एंड यहाँ पे कैपेसिटर्स लगे हुए हैं 0.1 माइक्रोफैरेड के फॉर द सेम पर्पस. एंड ये हमारी वोल्टेज को 3.3 में रेगुलेट करता है. So let's come to our ATmega 328P chipset. तो हमने Arduino Uno बनाया है जिसमें ये वाली IC यूज़ होती है एंड इसमें 28 पिन्स हैं एंड वी विल बी डिस्कसिंग ईच पिन. तो द फर्स्ट पिन इज़ बेसिकली द रीसेट पिन एंड इसमें जो है सिग्नल 1 का जा रहा होता है बाय द की बटन बाय डिफ़ॉल्ट. एंड अगर हम लोग इसको प्रेस करते हैं तो 0 का सिग्नल जाता है जिसकी वजह से रीसेट हो जाता है. बेसिकली इट वर्क्स द ऑपोजिट. यहाँ पे हमारे पास रीसेट की पिन है, वोल्टेज की पिन है, DTR की पिन है एंड रेजिस्टर्स एंड कैपेसिटर्स लगाए हुए हैं. और रेजिस्टर्स का इधर पर्पज़ ये है कि लेट्स सपोज हमारे पास करंट आ रहा होता है एंड वी वांट टू चेंज द सिग्नल. तो हम लोग की बटन दबाते हैं एंड the current instead of traveling to the IC travels to the key button and वहाँ पे हमारा ज़ीरो सिग्नल चला जाता है, जिसकी वजह से हमारा IC जो है हमारी रीसेट हो जाती है. The second and third pins are basically the RX and TX pins and they are basically programmable chips. and इसको हम लोग कनेक्ट करते हैं with our USB to TTL कन्वर्टर, जिससे हम लोग IC को कोड कर सकते हैं. फिर हमारे पास आ जाती हैं पिन नंबर 9 and 10 which basically is our oscillators pin. the oscillator circuit I have shown on the top left corner, and this basically provides the frequency to our IC which is 16 megahertz, and इसमें हमारा oscillator इस तरह पिन 9 और 10 पे चलता है. Circuit मैंने आपको oscillator का I have shown you before. Now coming to the pin number 7 and 20, basically it's our VCC pin जहाँ पे हम लोग इसको 5 वोल्ट दे रहे होते हैं, एंड यहीं से हमारी इसकी वोल्टेज आती है. The pin number 21 is basically reference voltage, and it's grounded from the left, and there is also a 0.1 microfarad capacitor attached to it for the same purpose. Now coming to pin number 8 and 22. Pin number 8 and 22 is basically the ground pins of our IC. यहाँ ये common ground के तौर पे act करता है, and this is basically the negative side of our IC. Now coming to pin number 23, 24, from 23 to 28, these are basically our programmable pins, and ये हमारी port C है. Port C की pins हैं ये हमारी, and these are programmable, and अगर हम देखें तो these are connected HDR6A, यहाँ पे ये connected है. नेक्स्ट हमारे पास पोर्ट डी आ जाती है, विच इज़ पिन नंबर 4, 5, 6, 11, 12 and 13. These are also programmable pins, and ये इनका बेसिकली सर्किट यहाँ पे कनेक्ट होता है. नेक्स्ट वी हैव आवर पोर्ट पी विच इज़ फ्रॉम पिन 14 to pin 19, and this is basically the circuit. यहाँ पे हमारी pins connected हैं, and there is reference voltage pin attached to and the ground pin too. And this HDR6P pin, इसमें हमारे पास reset pin आ जाती है. The 3.3 voltage we get from the regulator, and the 5 volts we get from the regulator. 2 हमारी ground pins होती हैं इसमें, and 1 is our V-in pin. यहाँ पे हमने एक रजिस्टर के साथ एलईडी कनेक्ट की हुई है और उसको भी ग्राउंड किया हुआ है, ताकि हम लोग चेक कर सकें कि इट्स वर्किंग और नॉट. सो दिस इज़ बेसिकली द स्कीमेटिक डायग्राम ऑफ आवर आर्डिनो प्रोजेक्ट. Now coming over to our PCB layout. So this is basically the PCB layout we have designed, and इसमें 3 जगहों पे जंपर वायर्स यूज़ की गई हैं. दिस इज़ आवर बैरल जैक, जहाँ से हम लोग वी गिव द इनपुट. यहाँ बेसिकली इसके साथ हमने 2 कैपेसिटर्स अटैच किए हैं, C6 एंड C1, विच आर बेसिकली 10 माइक्रोफैराड कैपेसिटर्स, एंड इनमें 2 voltage regulators भी हैं, the 5 volt one and the 3.3 volt one, and on the left there is a diode. यहाँ साथ में हमारे पास फीमेल हेडर पिन्स मौजूद हैं. On the right there is our USB to TTL converter. यहाँ पे हमारा crystal oscillator attached है with 2 0.1 picofarad capacitors. On the left there is a resistor, 2 LEDs, and again a resistor, and on the lower side there are again 2 female header pins. On the right there is again a resistor with a push button. So this is basically how it works. यहाँ से हमारी input जाती है, it travels down from the diode, goes to the resistors, the LEDs, to the ICs, and this is basically the TTL converter. यहाँ से हम लोग इसको कोड वगैरह करते हैं IC को. This is our main IC which has 21 pins. So yes, this is basically the PCB layout of our Arduino Uno project, the project 0. And next we will discuss the components list which we have used. So this is basically the components list. इसमें हमारे पास कैपेसिटर आ जाते हैं, and resistor 0.1 microfarad capacitor, that's 33 voltage regulator, 8 mega 328 pin, 22 picofarad capacitor, one diode, DC parallel jack, header pins, LEDs, resistors, 7805 regulator, TTL converter and a crystal oscillator. ये इसमें quantities लिखी हुई and the pricing of this. So yes, this is the animated view of our PCB. ये DC barrel jack है with the capacitors, the voltage regulators, diode, resistors, LEDs, header pins, TTL converter, push button, ceramic resistors, and our crystal oscillator, and in the center there is our IC. So this is basically the hardware PCB which I have made, and my name is printed with my roll number, and इसमें हमने properly each component को हमने solder किया है, and there were some issues with the soldering iron, that's why थोड़े से वर्क जो है थोड़ा सा मिस बन गया था, but I made sure कि nothing is short or open and it works perfectly. I'll show you the video right now. And this is the front side. So yes, हमारा PCB यहाँ पे complete होता है, and I made sure कि सारी components are correctly placed, and I have tried to run it, but there were some issues, maybe because of some faulty components, जिसकी वजह से it didn't work as expected. So some component got burnt, that's why we couldn't troubleshoot the issue, and plus there was shortage of IC in the market, जिसकी वजह से हमें थोड़ा सा डिले देखने को मिला अपने प्रोजेक्ट में. Now I'll be showing you the whole process of how we made the PCB from starting till the end. So first हमने print निकलवा लिए थे on the glossy paper or butter paper you can say, and we bought our PCB boards and we placed it on the PCB board, and then we ironed it till the print gets completely printed on our Arduino board. And this is how I ironed it at home. I'll show you the video. It's a time-taking process and it requires a lot of hard work, plus we have to be careful at each and every step कि कोई गलती ना हो जाए हमसे. This was our print basically, and the print was perfect. Then the next step was to use FeCl3 to remove the unwanted copper that we don't need from our PCB board, so that we can only get the wires or our design which is required. So FeCl3 basically हम लोग use करते हैं with warm or boiling water, and we dip our Arduino board, not Arduino board, the PCB board into it, and the copper slowly gets washed away. It dissolves in the FeCl3 solution, and this is how we have done it in our home. ये थोड़ा सा mess बन गया था because of the kettle, we boiled the water and stuff. The next part was to remove the ink, the print we had, so that we can get our copper design, the design of which we have printed. So to remove that black print we have to use petrol, which is one of the solutions which everyone uses. So it also requires a lot of hard work and a force too. And I was doing this on my bike. I used the petrol for my own bike and I was doing it with the cloth. It was actually rainy season, so it was a little difficult too, but this is how I did it. एज यू कैन सी ये ऊपर से जो है इंक का प्रिंट स्लोली उतर रहा है, एंड वी कैन सी आवर कॉपर प्रिंट डिज़ाइन. So another part is done to here. The next part is drilling the holes according to our PCB layout, जहाँ पे हमने drills करके components fix करने होते हैं. So I did this in the university project lab in our department, and it was a time-taking process, and it requires light and some proper focus so that we can have precise holes without any problems. So this is how I did it in the project lab. So yes, this was the drilling process of our PCB, and the next process is assembling the components on the PCB according to the layout. And after putting the components, the PCB board looked like this. इसमें कुछ components missing थे because there was some shortage of components in the market. Plus लेकिन ट्राई किया हमने कि जितने कंपोनेंट्स हैं उनको यूज़ करके हम लोग जितना मैक्सिमम उस वक्त तक कंप्लीट होता है अपने सर्किट को कंप्लीट करें. एंड यू कैन सी वी हैव प्लेस्ड द कंपोनेंट्स अकॉर्डिंग टू आवर पीसीबी लेआउट. And this is the part where I was soldering my PCB. I couldn't record the soldering process because I was doing it alone, and उसमें थोड़ा फोकस वगैरह चाहिए होता है, तो there was no one to record the PCB, the soldering video. And again this was the final part after soldering. अभी इनकी हमने components की वायर्स कट करनी थी ताकि हम लोग the circuit can be properly analyzed by our teacher. And this is how the soldering part was done. And yes, you can see our PCB hardware is all ready. We had used some jumper wires too. So yes, here our PCB boards get completed, and after this we tried to give power to it using the DC barrel jack, but it didn't show any sign, you can say any sign of life according to the circuit. So we tried troubleshooting it using digital multimeter to check if there were some shortage or some open circuits, but there were none. And at this time the IC wasn't available too in the market, so we bought the IC later on. But we tried to power on the circuit, but it didn't work. So maybe it was because of some burnt component or some faulty component, and but the design was working in the simulation in the Proteus and ESADF file. So we tried to troubleshoot it, but it didn't work. So this was my Arduino project basically. So yes, this was basically the whole journey of our Arduino project 0, which we tried to complete as soon as possible in the given deadline. Although there some thoda sa delay हो गया था इसमें because of the components and the shortage thing from the market, but we managed everything. And although the project, our circuit didn't work, but we gave our best के चल जाए किसी तरह, and we would test it using the blinker circuit, but it didn't work. So yes, this was my journey of our Arduino project given by Sir Umar Farooq in our course. So I did get many things to learn from this, especially in the some parts such as drilling and soldering, जिसमें मेरे first time experiences भी थे, because usually we used to make it in groups, but this time when we were alone, so it was a little difficult for me. But yes, this was the journey, and I hope we get more such projects in the future so that we can focus and learn for the betterment of our future. And obviously it brings opportunities for us and gives us skills too. So yes, this is from my side. So until then, we will hope so we will do another project soon. Okay, Allah Hafiz.